Okay, so we're given an inequality here, and we're supposed to determine which of these points are actually solutions for the inequality, just to kind of give us a little more understanding of how an inequality works with two variables, x and y. So in each one of these inequalities, the first number is always your x, and the second number is always your y, just like in any ordered pair. So for the first ordered pair, I'll see if it works. I'll plug in 1 for x and 5 for y, those two. And the question is that greater than -3? So we simplify. Yeah, that's definitely greater than -3. So the answer is going to be yes. So we try another one. How about the next one? When x is -2, y is 0. So we plug them in. And is that bigger than -3? I don't know. No, it is not. So that is not a solution. And that's all you do for each of these. Okay, so you're just going to plug them in and see if they work. Now we're going to graph the inequality. Now in previous topics, graphing the inequality meant doing it on the number line because there was just one variable. So there was only one axis, the x-axis, the number line. But now we've got y, and so we've got a second variable, so a second axis. So to graph these things, you want to get y all by itself, which it already is. It's all by itself on the left side. That's why that's what defines it to be in slope-intercept form. So the slope is always once y is by itself, the slope is the number multiplied by x, the coefficient of x. And whatever's being added or added to to x, that's the y-intercept. So we'll start with the y-intercept. So we know that the y-intercept is -2. So we get that cute little thing there. Actually, you know what? How about I do? I'll do hearts. Yeah, that's cute. All right, and then let's see. So, I'm going to want to change colors for this. Okay, so now the slope is -4. So and it's easier to graph when the slope is written as a fraction. So I just slip a 1 underneath it. Okay, so slope is always rise over run. Rise over run. So from the point we've already graphed, we're going to go. We're going to rise -4, so down 4. If it was +4, we go up, and then run 1. Okay, and then we get another point. I don't know why I'm using hearts. Okay, I'm not turning in my man card. Okay, so now we got 2 points on the line. So now I can play dot to dot, draw a perfectly straight line, just like I always do, and then we're good. Now, if this were an equal sign right there, we'd be done right now. Okay, but it's not. It's a less than or equal. Now, it has the or equal sign in it, so that's why we're doing a solid line. This red line is solid, it's not dotted. And the less than sign says we're interested in points that are less than that line. So everything that is below the line is a solution. Just like in the last topic we did, if you pick some point like right there or right there, they're in the shaded region. You plug them into this inequality, it's going to give you a true statement. And that's how we do it. Now here's a little bit different one. Now it's not in slope-intercept form. I know that because y is not by itself. So the first thing I got to do is get it in slope-intercept form. So I will add 3x. Oh, whoops, I got to turn on my pen. I don't want to change colors. That one's hard to see. I will add 3x to both sides. And then I'll divide both sides by 2. Now it's in slope-intercept form. Okay. So let's grab, let me go black. This. Okay, look how beautifully straight those lines are, just like the ones I draw freehand. Please no comments about it. Okay, so the just like before, the y intercept is the number that's not being multiplied by x. So -3. And this time, let's do this. Okay, so there's my y-intercept, that cute little star. All right, and then the slope is the number multiplied by x, 3/2, and it's positive. So we're going to go up. Positive slope means that from left to right, it's rising. Okay, so then we're going to go up 1, 2, 3, and then so we rise 3 and we run 2, rise over run, and then so we're going to go run 1, 2, and then that lets us a little point right there. So now we can draw the line because we got 2 points. But you'll notice that this line, or this inequality, does not have the or equal sign. Therefore, it's going to be a dotted line. Okay, so it's going to be this kind of guy. Wow, that's surprisingly straight, especially for me. Okay, so we get a dotted line. The dotted line is like an open circle on what do you call it? The number line. Meaning, okay, everything up to it, but not the dotted line itself. Now this time we have a greater than sign, which means we want to shade in points that are above the line, that are greater than the line. So we shade all this in, and it's just incredibly fun, and it looks like that. Okay. Now you can do that on your calculator. Do the graph, and let me do that with you in a second. So to see that graph on your calculator, you plug it in when it's in slope-intercept form. Okay. Now, if I just go straight to the graph, I see that, which looks really familiar. Okay. But it's not dotted, and I mean, you could do dotted, but it's not really worth it on the calculator. So you just have to know that it's dotted. But I want to shade above. So if I go to the left of Y1 and hit enter, if you have a black and white calculator, you're just going to use the left and right arrows. But if you have the color one, it looks like this. So then I will go down here to line and say, use the right arrow to get that symbol. That means shade above. If I hit it again, it means shade below. All right, so then I'm going to do that. So now instead of just drawing a line, it'll shade above and give me what my solution set looks like. So any point in this shaded region plugged in for X and Y here is going to give you a true statement. So what if we have a system of inequalities? A system of equations or inequalities just means you got 2 of them. But together they form the entire, they tell the whole story of what's going on in that problem. So we start off the same way we did on the last one. We get them both in slope-intercept form. Okay, then we can actually graph them. So if I take that first one, -7x plus 4y is less than -4. Okay, so I'm going to add 7x to both sides. And then divide both sides by 4. Okay, and I've got that. So a y-intercept of -1 and a positive slope of 7/4. So if it's a positive slope, that means from left to right, it's going up. If it's a negative slope, from left to right, it's going down. Okay, so how about the other one? So 7x plus 2y is greater than 2. So I'll subtract 7x from both sides. I'm going to write it like this because I feel like it. And then I'll divide both sides by 2. And we get negative 7/2 for the slope. So this one is going to be going downhill, downtown Brown. Okay, so I could graph them both on the on paper. That'd be fine. I'm just going to do it on the calculator. Just give us more practice. So I'll meet you at the calculator in a moment. Okay, so there's my two statements right there. And you'll notice I didn't bother writing 7/4. I just said 1.75, and 7/2 is 3.5. So, it's cool. So, if I graph it, I get that. And remember, they're both dotted lines. Okay. So you have to remember that when you're putting the answer in Alex, they're both dotted lines. But what else would be super cool is if we had the shading in there. So remember, the first one was a less than sign. Okay, so we got that. And the second one was a greater than sign. Oh, I guess that was it. Okay. And so now when I graph them, I get this. And so the solution set is only where they are both shaded. So right over here, nope, that's not part of the solution set. Here, nope. Over here, absolutely not. So your solution set is just all of this rich, creamy goodness. Okay. And that's it. Well, this is just like the last one, except now there's an extra inequality. But it's easier because it's already in slope-intercept form, all three of them. So that's pretty sweet. So this time I'm just going to do it on the computer, just because might as well, and instead of the calculator. Okay, so whoa, what is that? I don't know. Okay. But it looked kind of cool. Okay, so the first one, y is less than or equal to -7. So first of all, I know I'm going to have a solid line because it's or equal. The less than sign says we're going to shade below. And this is just, the y-intercept is -7, and the slope is 0, as in plus 0 times x. Okay, so we're going to go to -1, 2, 3, 4, 5, 6, 7. Hope I don't need to go any lower. Okay, so that's where the y-intercept is, and the slope is 0, so it's just a horizontal line like that. Okay, and it's solid because it has the or equal. Now, it says less than, so we shade below, and I'm going to try and keep my shading nice and clean because I got 3 of these statements, and I don't want to get lost in a big mess of shadings. Okay, the second one, right there. I better change color. That'll make it easier. The second one has a y-intercept of 4 and a slope of -5, or -5/1. So I go down 1, 2, 3, 4, 5. So I'm at that height there. Okay, and then a run of 1. So whoops, I drew that a little too big. Okay, there we go. So there's my point. So down 5/1. Now this one does not have the or equal sign, therefore it's going to be dotted. Okay, and it says less than again, so we're going to shade below. So I'll do this. So far we know our solution set is somewhere down here. It can't be anywhere else so far because every other place is only shaded in at most one time. Okay, cool. Now the last one, this is way easier with multiple colors. The last one has a y-intercept of 4. I mean -4, sorry. So 1, 2, 3. So right about there. And it has a slope of 5. So 5 over 1. So up 1, 2, 3, 4, 5. So our new height is right there. And then a run of 1. So we run over to the right 1. And it has the or equal. So it's going to be a solid line. And this one also is shade below. So I'll just shade diagonally, because I've already done vertically and horizontally. And so our solution set is going to be everything where all 3 of them are shaded. Okay, so that's going to be this region right here that just keeps going down forever and ever and ever. Okay, and that would be how you do it. All right, so on this one, all we're doing is writing an inequality statement. We're not graphing it or solving or anything, just practicing writing it, which is good practice for for word problems, which, well, this is a word problem. Okay, so a landscaper is planting a tree that is now 57 centimeters tall, and it's going to grow 4 centimeters every month for X months. The tree will grow to be at most 5 centimeters tall. So write an inequality showing this relationship. So it's right now it's 57 centimeters, and that height is going to grow. So plus, if it was shrink, it'd be minus, and it'd be a very weird tree. Grow 4 centimeters every month for X months. Okay. And that is going to be keywords at most. So less than or equal to whatever that ultimate height is. Y is the biggest height it's going to be. And so however much it grows is going to be no more than that maximum height. It'll be, yeah. So that is how it goes. And so, yeah, you just practice doing these. They're really good practice. Help you with word problems. All right, pause the recording to read the problem. Okay, so we've got Carlos here, and he's doing all kinds of exercise. And he's doing, well, more specifically, two kinds of exercise. Okay, so so Y is going to, oh, I gotta turn on my pen. Y is going to be weight training time. How many hours a week he's weight training. And X is going to be how many hours a week he does cardio. So X is cardio, Y is weight training. All right, cool. And so now we need to create inequality statements that represent all the stuff that's written above. Okay. In fact, I'm going to just say X and I'm going to say Y, because I think this makes it easier for me, at least, keep track of what's going on. All right. So, I think I'll change colors because I don't know, why not? Okay. So Carlos does a weekly exercise program of cardio and weight training. Cool. No inequality statements there. But in the second sentence, each week he exercises for at least 10 hours. So the hours he spends on cardio plus the hours he spends on weights is at least greater than or equal 10 hours. Okay, so I've got one statement. He spends at most 8 hours doing cardio. So the number of hours he does cardio is at most, or no more than, less than or equal to 8. Okay. He spends at most 12 hours on weight training. So number of hours weight training is at most 12. And then they say, all right, now go do all your stuff. Now, there's actually more inequality statements that they want you to do. They want you to recognize, even though they don't say it explicitly, that, well, since X stands for the number of hours doing cardio in a week, X has to be at least 0. It can't be negative. It wouldn't make any sense. And the number of hours doing weights each week has to be at least 0. So it's just you know, just 5 little guys there. Okay, very nice. So what we're supposed to do is shade in the solution set. So we just shade all 5 of them in. All right, now, first of all, on these last 4, there's only 1 variable each, and the variable is isolated. So that's good. They're all ready to roll for graphing. But on the first one, both variables are on the same side. So if I subtract x from both sides, I get y is greater than or equal to 10 minus x. Okay, so there. Now all 5 of them, all 5 inequality statements are written with y by itself, and when there's no y, with x by itself. Okay, so let's get into it. Down and dirty. Here it is. So I'm going to need those guys, and I'm not going to be able to draw real big here because, well, there's not too much room. Okay, so let's see. So we got to go all the way out to 12 and 8 and stuff like that. Okay, so the first one has a y-intercept of 10. I'm just going to estimate. Is that okay with you guys? Well, you know what? Let me do this to make it a little easier. I'm going to zoom that out a little. That'll give me more room. Hopefully you can see what I'm doing a little better. Okay. All righty. All right, and I'm just doing a freehand line there. That's okay. All right, so the first one right here has a y-intercept of 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we've got a point. And the second one has the slope is -1, as in -1 times x. So down 1 and right 1. And everything has the or equal, so everything's going to be a solid line. Okay, so that's a little bit simpler. And this one has the greater than sign, so we're going to shade above. Okay, next one. You know what? I'm going to, yeah, I'll just take them in order. Okay, so x less than or equal to 8. Now this one only has x, which means it's a vertical line. Where's that vertical line? Well, at 8. So if I go out to 1, 2, 3, 4, 5, 6, 7, 8, I'm going to get a vertical line right there. Now, I don't know from my drawing, because I'm not drawing perfectly well, I don't know if that vertical line hits right there where the red line hits the x-axis or not. Probably not, but you know, maybe. Okay. Now, we've got that line, and it says I'm looking for x values that are less than 8. Well, x values that are less than 8 are to the left of 8. I guess I didn't need anything more than the first quadrant, did I? I mean, obviously nothing's going to go in the second, third, or fourth quadrants because that's where things are negative. Okay, cool. We got that. Next one, we're looking for y less than or equal to 12. So that's a horizontal line at height 12. And it says less than, so we're going to shade below. Isn't this fun? It's like art class, except it's something you really, really want to put on the wall, right? Okay, so far our solution set is going to have to be somewhere in here, right? Because that's where everything so far is shaded at. Okay, now we need this guy here, and all that says is we only want to use positive x values. All right, whatever. So let's pick that color, I guess. So x equals 0, that's the y-axis, and it says we want x values that are greater than 0. So that would be over here, and it's really getting tricky to see, even though I'm trying to be really clean with it. And then the last one says I only want positive y values. So the x-axis on up. So that was terrible drawing, even from by my standards. That's saying something. Okay. So there's y equals 0, and it says shade above. So I'll just go vertical again. How about that? Okay, a little bit tricky, but the region where everything is going to be, I'm picking a new color. It's going to just be, let's see, what is really busy. Okay, it's going to be this region here. All right. That's the region. That's where everything is shaded in. Now, here's the deal. So, you might have, if you are Carlos, this graph on the wall and be like, okay, I really want to stick to my regimen here. You know what? I only feel like doing 3 hours of cardio this week. Okay, well, x equals 3 is right here. I know, it's hard to tell. And so he's like, okay, I only want to do that much this week. Okay, which means I need to do between this much, which I can't tell anymore. Looks like about 1, 2, 3, 4, 5. Looks like about 6 hours of weights. It's like, so if I only do 3 hours of cardio, I'm going to have to do 6 hours of weights, somewhere between 6 and 12 hours of weights. Okay. And then that helps him to stick to his exercise regimen. He just knows I have to be somewhere in here. Okay. And that is how it is done.